This is going to be our enzymes video. Enzymes are a type of protein, so they go along with that category of macromolecules. Enzymes are going to be workers in your cells that help chemical reactions happen. Some chemical reactions, they would happen too slowly to happen naturally to get anything actually done. So enzymes help us get stuff done on a quicker, more timely basis. So many chemical reactions in the cell have this sort of a graph where on the y-axis we have free energy, which we're not going to talk that much about. And on the x-axis they have sort of the time of the reaction. So on the left is the beginning and the right is at the end. And so you'll see that the reactants have a certain amount of energy and the products have a certain amount of energy. And the reactants have higher energy on this scale than the products do. However, so you think sort of it's like a slide, it'll ultimately go down. However, you'll notice this big hump in the middle of the graph, so you actually need to go up in energy before you can go down. And this change in energy from where the reactants are upwards, this is called the activation energy. That's the energy needed basically to start the reaction. And so when enzymes are present, they actually lower that activation energy needed to run the reaction. So notice we have two lines in this picture here. The solid one is the activation energy without the enzyme, and the dotted one is the activation energy with the enzyme. So it's not that the activation energy goes away, it still exists, but it is significantly reduced, and this makes the reaction more likely to happen. And notice that that is the only thing that has changed about this graph. The reactants are still the same, the products are still the same, the overall energy is still the same, but the actual amount of energy that it takes to start the reaction is incredibly different. Enzymes basically look like big blobs of folded up protein. If you see them in a textbook or in a picture, they basically look like this sort of a shape. And you can look up really scientific, more accurate pictures of these, but blobs are okay for this class, I think. Enzymes have an active site where the reaction that they control happens. So this sort of opening in the enzyme is its active site. And the item that the enzyme works on is the substrate. Okay, so here we have two substrates. Here we have an enzyme with its active site. And together, when they come together like this, they form what is called the enzyme substrate complex. Sort of two things coming together. We have this large complex of when the reaction is happening. And at the end, we have the enzyme and the product. So here are some of those definitions. The substrate is the substance the enzyme works on. The product is actually the substance created at the end of the reaction. Now, in the past pictures, we were taking two things and making one thing, sort of joining them together. It could very easily be that the enzyme takes one thing and breaks it down into two products. So the quantity does not determine if it's the substrate or the product. It's merely what's there at the beginning, that's the substrate, and what's there at the end, that is the product. Enzymes are awesome, and you need to continue to think that enzymes are awesome. Enzymes are awesome because they never get tired. And they never get used up. They just continually work. You don't have to give them breaks. You don't have to pay them overtime on holidays. They are awesome, okay? Enzymes continue to work on their substrates until they run out of stuff to work on. So if it's done working and I give it more stuff to do, it will continue to work on that. And it won't stop until it is done. Things that prevent enzymes from working are going to be temperature and a pH change, and these things will denature the enzyme. When we talked about denaturation with proteins, and enzymes are proteins, so it makes sense that these two items especially that denature all proteins will denature enzymes. Enzymes happen to have a pH and temperature where they happen to work their best. That is their ideal pH and their ideal temperature. Anything outside of those ranges will be bad for enzymes, and it's not going to be the same for all enzymes. The pH range of enzymes that work in our stomach will be lower and more acidic because it'll be happier there than enzymes that will work in other cells in our bodies. And so it's not going to be the same even within organisms. pH and temperature ranges will just be very different based on what they're doing. The other thing that you need to know about enzymes is that enzymes are really, really specific. Enzymes typically work on only one substrate and are actually typically named after the things that they work on. So for example, lactase works on lactose, the carbohydrate. You should know that both lactose and sucrose are carbohydrates because they end in that ose. Sucrase will work on sucrose, and you might have noticed a pattern here. All of our enzymes will end in ase. And so if you see the name of an enzyme, you should be able to recognize it because it ends in ase, and it will typically, not always, but typically be named after what it works on.